As the man says, my name's Russ Olsen. I have been around the Ruby community for a long time. I work for a company called Hashrocket. I've written a couple of books that I'd like you to buy many, many copies of. Before I really get started, I want to say that I help organize one of the other Ruby conferences, Ruby Nation, and I got to say, it's a pain in the neck. Getting everyone here takes more effort and more aggravation than you could possibly imagine. So I'd just like to thank the Hashrocket guys and everyone else who, well, the Hashrocket women too, everyone else who has had anything to do with this conference. So on to the topic of the day. What I want to talk about, this morning I'd like to step back a little bit and talk about the things we do and how we do them. And in particular, I want to talk about insight and intuition. And I'd like to start with a question. And the question is why, okay? And it's why is the experience of programming what the experience of programming is. So I don't know about you, but here's how I spend my work week. Tuesdays, Thursdays, and Saturdays, I'm happy, I'm coding away, everything's going brilliantly. Mondays, Wednesdays, and Fridays, I alternate between staring at the screen and banging my head against it. Right? Programming is really hard. What we do is really, really hard. And so the question I want to start with is why is what we do so hard? What makes it so difficult? And I think if you remember back when you were first learning the program, it was a surprise, right? You get this, once you first sort of knew how to program a little bit, and you get some trivial little exercise you tried to do, some trivial little program you wanted to write, and it would be really hard, and it was kind of a surprise. And certainly in the early days of programming, I mean, software was invented to keep people from having to like program computers by plugging wires in, right? Oh, we're going to do this in software, and it's going to be so much easier. How did that work out? So it was a surprise in these early days. This is a guy from the 1940s, sort of at the beginning of what we do, and his name was Gray Walter. And he was active in those very early days when we were first doing programming, and I think he actually discovered why what we do is so hard. What Gray Walter did was he was trying to simulate animal behavior like seeking food and avoiding obstacles, and he built this little robot, which is the first of its kind. If you sort of do the Make magazine kind of thing, people will build robots that will run around the floor and bump into the wall and back up and go in a different direction. At home, I have a Roomba, a little vacuum cleaner that basically does the same thing. This was the first one. Gray Walter called this thing a turtle because he had like a plastic shell or metal shell that went on it. It looked a little bit like a turtle. And he built some actual hardware software so he could let this thing go and it would bump into obstacles and back up, you know, the kind of toys that people build. And let me tell you, it's a kick to build. If you've never built something like this, it's really a lot of fun to do this. And I'm sure that he had a lot of fun doing it. And one of the other behaviors that he built in that I tried to represent up there at the top is if the battery ran down on the thing, it would go seek out a charger. There was a light above the charging station, and it would go find the charger and plug itself in and recharge, and then it would back up and run around for a while and do that over and over. And it was all very simple. It was just some analog circuits. People estimate that maybe there were 2 or 4 neurons worth of intelligence in these things. The funny thing is, well, you can imagine, he actually built 2 of these. And, right, so you built 2 of the coolest things you could possibly imagine. What do you do with them? You let them run all the time, right? You turn those suckers on, you just let them run. Funny thing would happen is if you let 2 of them run at the same time. He would come back after an hour or 2, and one would be stone dead, and the other one would be running around. Or one would be upside down, kind of ironic because he called them turtles. And the other one would be running around. Sometimes he'd come back and they'd both be dead, right? So what's the deal with that? Turns out that if they both get hungry at the same time, they both start to head for the power charger thing. There's only one power charger thing, and they bump into each other. So they'd back up and then do it all over again. They'd go and they'd hit each other and they'd back up, and basically they'd fight to the death over the food. he didn't intend, when he did the circuit, he didn't intend for that behavior to come out. It just kind of fell out of the design. It just kind of happened. And that's why I think programming is so hard, because programming is all about emergent behavior. We write some code, and we're hoping that from very, very simple code, something like this, we're going to get an accounting system out of this thing. We don't care. Nobody cares if we can increment the counter. What we want is an online storefront or a personnel system or whatever else. So we rely on emergent behavior. The problem is that there's emergent behavior we like, and there's emergent behavior that ends up with a dead turtle, right? And it's hard to control emergent behavior. So we are, in a sense, in the emergent behavior business. Everything we do is about getting the right behavior to emerge and keeping the wrong behavior from also emerging or emerging instead of what we want. And which brings me to the topic of my talk, which is that we like to think of ourselves as kind of doing logical, almost semi-mathematical kind of work. And so if you fix a bug, right, somebody will say, how did you fix that bug? And you say, well, I deduced that this was going on, and then the pointer was wrong, and then that happened. No, that's not how you fixed the bug. What you did was you stared at it for 2 days, you banged your head a little bit, and then suddenly it came to you, right? So we pretend that this is the kind of stuff we're doing. We're doing this purely logical stuff, when in fact we're really doing something completely different, right? Socrates does not know why the robots fight. And so what I want to talk about is kind of those aha moments. What happens after you get done banging your head on the LCD screen? What happens, what is really going on when we do the real work of what we do? So the question is, where do those aha moments come from? And the bigger question is, how do we get more of them? How do we, when we're stuck, how do we get unstuck? Okay, so that's insight and intuition. How does it work, and how do we get more of it? Well, here's one thing. It's not magic, right? We tend to treat it like it's magic. Oh, I don't know. I sat there for 2 days, and suddenly the answer came to me. It's not magic. It's got to do with this whole left brain, right brain thing, so no, I'm not going to go all psychological on you or anything. But I think it's true that our minds are specialized, okay? It seems to be true that for most people, the left side of your brain does the logical, the language kind of stuff. The right side of your brain is more creative, it thinks in pictures, okay? I think there's something to that, right? It is, in fact, the right side of your brain that looks at that and says, foggy highway near a forest, right? I could have taken that picture outside today, but I didn't. The thing with this whole left brain, right brain thing that when people talk about it, they never, ever say, as far as I can see, is the fact that the two halves of your brain share some common resources. It's like you got a dual CPU setup, but there's only one network card. There's only one disk drive. And what that means is that they both cannot operate at full steam at the same time. And that's key, okay? They share some common resources. So how do they work? Well, I think for what we do, how it works is you got a bunch of facts floating around in your head, right? So here I've got like the turtles seek the charger, turtles back up in collisions, but all the facts you know. So among the things that I know with metaphysical certainty is down there at the bottom, which is bacon is good, okay? So it's everything you know. And there's some background process that's pairing these facts up, right? Turtles seek the charger and bacon's good, that's probably not the most helpful thing in the world, but turtles seek the charger and only one turtle can charge at a time, that is on its way to something, and that's sort of interesting. So I think when you're banging your head on the LCD screen, what you're doing is you're kind of pairing up these facts in a background process, and eventually you're going to come up with some facts that, give you some illumination. Which brings me to my first bit of little practical advice, which is you need to select the facts carefully. And what I don't mean by that is you need to sort of focus in on, I'm going to live, breathe, and eat software engineering for the rest of my life. What I mean is you need to filter out the noise, right? There's so much noise in programming that it can overwhelm you. So what is that? Anybody recognize that? It's a Rails log file. We all know them. What do you find in a Rails log file? Mainly you find two things. You find information about HTTP. I got this GET request. I got this POST request. And you find things, active record-y kinds of things. I put this in the database. I did this select statement. Why do you find all that stuff in a Rails log file? You find that stuff in a Rails log file because that was Rails's original purpose for being. Rails was originally a thin HTTP veneer over a relational database, right? That's not true anymore. People haven't paid me for a really long time to write thin veneers, thin HTTP veneers over relational databases. The applications that most people are building today, I bet a lot of you, with Rails are a lot more complicated than sort of the stuff that's in here. And you know what else? We've gotten pretty good at HTTP. Active record's pretty good. We don't really need all this information to debug our applications, and yet, when we try and debug our applications by putting in log statements, we put it in with all of this stuff. And there's this huge pile of I don't care facts in our log files. So what I try and get people to do is create a log file in the Rails application that is only for the higher level, what the heck is this application doing at some high conceptual level. So this is just an example of sort of don't pay attention to extraneous facts because they're exactly that. And they disable your ability to get at the insights that you need. So would you rather look at that or that hidden somewhere in there, right? Now, obviously, you could do this with some kind of filtering. I just find it easier to create a separate log file. But the point is that you need to filter out the noise. And sometimes, literally, you need to filter out the noise. Who here pairs? A lot of people pair? OK, I pair a lot. And I actually do a lot of remote pairing, which is I've got tmux and I've got Skype running, and I'm talking to this person somewhere far away, and we're working on the same project. And if you think of the experience of pairing, what do? You talk a lot, right? Oh, I'm going to do this and I'm going to do that. And we also feel like we're agile. We want to be agile. So there's always something in motion, right? You're moving, you're doing things, you're looking for the new gem and stuff like that. And then we hit one of these problems that we need some insight for. And typically what happens is that generates an even bigger flurry of activity, right? We're trying furiously, we're trying all the gems, we're doing this and we're doing that, we're talking back and forth. So here's a suggestion. Just be quiet for a while. Declare a 2-minute, we're just going to think and stop talking. Because remember, the two sides of your brain, they share common resources. You cannot talk and think creatively at the same time, or you can't think creatively as well if somebody's talking, if you're furiously looking for the new gem version. That's what that word was. Just declare a moment of silence, and for 2 minutes, don't talk to each other. You'd be amazed what ideas pop out of that. Here's another idea. Change the facts. We tend to build applications and we give it some sample data. If this is like a personnel kind of system, you get some sample data, right? I got 4 phony people in there. And if something goes wrong with it, we run the system with the same sample data over and over and over. Well, here's a counterintuitive thing that actually works. Change the amount of sample data. Instead of 4 people, have 7. If you got 7, try 4. Just change it a little bit. Now, the logical side of your brain will say, that cannot possibly make a difference, right? The amount of my junk data cannot possibly make a difference. Logically, this will not make a difference, okay? Logically, your brain does not know logically why the system isn't working in the first place. So logically, the logical side of your brain should shut up, right? The intuitive side of your brain will see patterns that it won't see if you just stick to the same amount of data. So even stranger is you take some real names, real people, and you stick them in instead of like fake names, and you try that because that may jog something. So use real names, real people. The other, I have to stop here for a minute. I just said these were real people, and nobody said a word. It worries me a little bit. The other thing you can do is break your system, right? Just put some junk data in there and see where the pieces land. Right? This is the equivalent of trying to get insight into how a car engine works by sticking a screwdriver in it. It works sometimes. And the advantage of this is that line of junk data will not come flying out and take a piece of your ear off. So try that. The other thing you can try, if you're looking for some insight, if you're looking to jog up your intuition, is to see the stuff happening in real time, which is a very fancy way of saying, just tail your log files. Try and get information that's happening in time. So again, the logical side of your brain is saying, well, if I look at the log file and this came before this, I logically know that this happened before that. Yeah, that's true. But seeing it happen is something different. Seeing it makes you believe it with both sides of your brain, okay? The intuitive side of your brain is not so convinced that this, because it's before physically, happened before this in time. And you need to convince it of that. Finally, well, not really finally, but there's also a warning I need to give you. And I think a lot of us fall into this trap a lot of the time, which is that when we get these revelations, the lightning bolt comes down and you say, I know what the good design is. I know what's going on here. You get this, flash of lightning. Remember that lightning is like 4 million volts and can do some damage. Just because it comes as a lightning bolt does not mean it's right. And as the perfect example of this, I give you this guy. This guy is Percival Lowell, or he was, I guess, because he died in 1916. He was one of those people. He was from prominent Boston family. He was born richer than rich. He went to Harvard. He then went off and made bazillions of dollars in business on top of what he inherited. After he got tired of doing that, he became a pretty world-class mathematician. And then, sadly, he turned his attention to astronomy. Percival Lowell had the misfortune to live right at the end of the era where astronomers actually looked through their telescopes. And Percival Lowell looked at Mars, and this is what he saw. He saw this network of straight lines with nodes, and he thought, there's got to be some intelligence there. There's got to be a civilization there. And so all of the bad science fiction you've ever seen about Mars and invaders from Mars and really bad science fiction, you can blame all of this. You can blame this on Percival Lowell because it was his ideas that people took really, really seriously that led to this idea that there's this old civilization on Mars with canals, okay? So if you look at the picture of Mars with those straight lines, it's absolutely clear. Those straight lines are evidence of intelligence. There's just no doubt about it. The question is, and there's Percival looking through his telescope, the question is the intelligence at the Mars end of the telescope or the Percival Lowell end of the telescope? And it turns out those lines are not there. Turns out that if you look at an object that's got spots on it, and the spots are just below what you can see, so they're just below your level of vision, the pattern matching software, the same stuff that gives us these revelations, I know what the bug is, that same stuff will turn those spots into straight lines with little nodes in your vision, and that is what you will see, and you will make a horse's ass of yourself. if you're Percival Lowell. We are wired to see patterns, right? What is that? It's a cloud. No, it's not even a cloud. It's some light and dark light on a white screen, right? There's no bunny rabbit there. I see a bunny rabbit. You have to watch out. Just because it comes to you and it seems like the most brilliant revelation and everything just falls into place, you need to be very, very careful of those things because they may not be right, but they will make you believe. And in particular, if you get a revelation or some intuition that involves numbers, particularly statistical kind of numbers, be very, very skeptical. My sister is afraid to fly, right? It's not that she's a stupid person or anything like that. It's that intuitively she believes that the numbers will tell you that it's a dangerous thing to do, even though we know that it's not, right? Lots of people are afraid to fly. This is a great quote. You know, buying lottery tickets does not significantly increase your chance of winning the lottery, and yet people buy lottery tickets because we're bad statisticians intuitively. And I'll give you an example a little more close to home, which is this. If you flip back and forth the way I do between sort of the Java world and the statically typed world and the Ruby world, you will eventually hear this argument, and it's a pretty compelling sounding argument. The argument goes like this. There's a whole class of bugs that you can get with dynamic languages, right? I think I have an employee object, and in fact, what I have is a nuclear missile object. And then I call fire. Oops. Right? You've heard, I mean, if you hang around with people who do static languages, that's what they'll tell you. And therefore, there's a whole class of bugs that you can get with dynamic languages, so I'm trying to illustrate that with the little red extra there, that you can't get with dynamic or static languages. Therefore, static languages are better. They're more reliable. They're safer. Except they're all here in this room. That is not the experience that we have in day-to-day programming. So what's the deal? Well, this is a numerical, statistical, chance-based argument. So let me just make up a slightly different situation. What if the number of bugs in any given program was colossal, huge, enormous? And yes, that dynamic languages add a few more on top of those huge numbers. I don't know if you can see it, the little tiny red bit up there on the right. Suddenly, this argument doesn't make much sense, or it doesn't seem very compelling anymore, and this is more like the experience we have. There are no shortage of bugs in programs, right? So if you add a few more possibilities and you get something back from them, might be a good deal, particularly if the chart looks like that and not like that. So in talking about numbers and intuition and programming, the other place you've got to avoid is the perfect storm of programming intuition. The perfect storm of programming intuition is when somebody says, hey Russ, can you speed this program up? It's taken too long, right? If somebody tells you to improve the performance of some code, that is the black hole of intuition. What are we trained to do? I give you some code and I say make it better. What are we trained to do? We go into the code and we look for the interesting parts. We look for the badly written parts. We look for the ugly parts. Or alternatively, we look for the well-written, beautiful parts, right? And if you give someone who hasn't done this very much a program and say, make it faster, the first thing they will do is go look through the code. And they'll look through the code, and automatically they are looking for the interesting parts, the good or bad or cool parts. None of that has anything to do with where that program will decide to take up a lot of time, right? Inspecting code is pretty much the worst way in the world to find out where a program is taking its time. You know what the best way is? You measure it. You just go in and you measure it, right? You profile the code. Every time anyone has ever asked me to make some code faster, I profile the code, and it's like, oh, wow, I didn't expect it to be there. How did that happen? And then I can start. Program performance is the perfect storm of bad intuition, and that's the place that you need to watch very carefully. The other thing that you can do, so that's sort of the negative side of it. The positive side of it is, how do you get better at your intuition or having insight? And one of the things that I think we sort of think as a culture that I believe is just completely wrong is that there are people who know the facts on one hand, and there are people who are creative on the other hand. I don't believe that, at least not in our world. There's people who are creative because they've mastered the facts. Maybe they've mastered the facts very quickly. Maybe they've mastered them in a different way, in a non-traditional way. But creative people who are making real progress have in some way mastered the facts. Chance favors the prepared mind is what Louis Pasteur said before he heated up his milk. So you know the book, 7 Languages in 7 Weeks. If you don't know that book, you really should. 7 Languages in 7 Weeks encourages you to go off and learn about 7 different programming languages in 7 weeks, right? And the idea is you may never use any of these programming languages, but maybe it will make you better. You'll have more facts, so you'll have better intuition. And I say, yes, do that and do more. The problem with those 7 programming languages is they're all fairly high-level programming languages, right? Go the other direction, go lower level or go really high level. I've sort of hidden assembly off at the bottom so I don't scare the children. But you know, there's a whole hierarchy of programming languages that you can look at that will give you insights into how things work. Ruby, if you're using the Ruby that most of us use, is implemented in C. Okay? I have an advantage. I was a C programmer for years. If you don't know anything about C, there are things that Ruby will do that you just won't get. And it doesn't take a huge amount of C to see that. That was unintentional. The other way you can go sort of in a different direction, right? Learn the solder, learn some electronics, right? Every program you've ever written runs on electronics. Why not learn something about that? Or go the other way and learn about operating systems and networks and that kind of stuff. Or alternatively, you can do what me and Jim over there do. You can buy yourself a ukulele, right? Learn about music or a foreign language or something like that. All of this stuff, all of these things like music, they're emergent systems, okay? They are systems that start with very simple things. The ukulele's got 4 strings, okay? But their interactions produce this very complicated emergent behavior, okay? So the more emergent behavior, the more systems that you're familiar with that have the same kind of emergent behavior that we're dealing with, the better you will be at it. If you like sports, why do some teams work and why sometimes do they not? Right? The sports teams are emergent systems. Why does that work as a painting? It's just some blobs of paint on a white canvas. Why does it work? That's Congress. I'm not going to ask why that works. Okay? But it is a complicated system with incredibly complicated emergent behavior. And if you think about politics, you know, you could think in terms of the politics of the software you're working on. Maybe that's an analogy that will take you a certain distance. So here's kind of a summary of all the things that I've said. But I just kind of want to go through that quickly because, and this is a true story, I wrote this talk and was sort of happy with it and then walked around in a daze for a couple of days. Like, it wasn't quite finished. You know, why do I feel like this talk is not quite finished? And then it hit me. And so here's the revelation I had. See if it's a perfect storm or something valuable. And it is this. We are in the emergent behavior business. Our whole job is we build these systems that we're hoping have interesting emergent behavior. There's all kinds of systems in the world, starting with Congress in the United States, but worldwide. There's, you know, the environment, there's our energy systems, there's how we educate people. These are all complicated systems that produce even more complicated emergent behavior. Everyone in this room knows more about emergent behavior than virtually everyone else in this city. Okay? We as a profession are in a unique position to be able to take the things we learn at work and go out and have some insight into the wider world. Why do the systems that are not computer systems, why are they working or why are they not working? I am convinced that we as a profession, the people in this room, have more to contribute in those terms than almost what we do on a day-to-day basis. So it's just something to think about, but I have this feeling, I go to a lot of conferences, I love you people, right? And I think you have more to contribute outside of your profession. So think about that. Thank you all for listening.